Chapter 4, Section 2, problem number 11. So here we have 5,000 lottery tickets are sold for $1 each. One ticket will win $1,000, two tickets will win $500 apiece, and 10 tickets will win $100 each. Let X denote the net gain from the purchase of a randomly selected ticket. Construct the probability distribution of X, compute the expected value, interpret its meaning, and compute the standard deviation. Okay, so we need to start off here with a probability distribution. So if we look, let's see what values can we have. So if you buy a lottery ticket and you're going to spend $1, so if we buy a ticket and you don't win anything, that costs you $1. So if we look at the values of X, and what the probabilities of those are, so there's some probability that we'll get nothing. Then we have the probability of winning 100. So we have 100, and if you win $100 but you spent one, then your outcome there for X is 99. Then we have the 500 but you spent one, so you could get 499. Or you could win 1,000 but you spent one, so that's 999. So those are the four options that you have, right? So let's look. So for winning 1,000, that's, let's come back up here to clean that off, extra drawing there. Come back again. So for the 999, there's one chance in 5,000. For the 499, there I put a 1 in there, but that's a 2, so 2 tickets could win. And then for 99, that's 10. So we have 10 possibilities out of 5,000. And then losing is everything else. So there's 13. So 4,987 possibilities of getting -1. Right, so there's our probability distribution. So compute the expected value of X. And for discrete distribution, this is going to be X times the probability of X. And that's going to be summed across all over all n. So in this case, we're going to have -1 times 4,987 over 5,000, 99 times 10 over 500, 499, 2 over 5,000, and 999, 1 over 5,000. So this times this, this times this, this times this, this times this, add those together. And when we do that, we wind up with the probability, or the expected value is -0.4. So the expected value -0.4, that means, for its meaning, what happens when we buy a lottery ticket, we expect to lose 40 cents. So we're not expected to get ahead, we're expected to lose. And then for C, compute the standard deviation. The standard deviation is going to be the square root of the variance, which is going to be, so here we have our equation for the variance, x minus mu squared times the probability of X. That's a 2. It almost looks like a 3, doesn't it? A 2. So squared. So we have to put all of our values in here. So we'd start off with summing. We'd have our first element will be -1 minus 0.4. That value squared times the probability, which is 4,987 over 5,000. Plus, we continue that for the other elements as well. So that value is going to wind up being the square root of 3191617, which equals 17.865. Okay, there are our values.